All right, so this is the carbon cycle. It's hard to draw it on the board the way I got it supported here, so I'm sorry I've got it already drawn out for you, but I'm going to lead you through it. The one you've learned since the third grade, you took plants and animals. You had plants giving off oxygen, and this is glucose or sugar, and going to the animal. The animal then gives off CO2 and H2O. This is respiration. This is photosynthesis. For the sake of ecology, you want to think about this a little bit differently. Plants aren't the only ones that actually undergo photosynthesis. You want to call it producers. And animals aren't the only ones that are taking in that sugar and giving off CO2, so you want to change that to consumers. However, to really get it correct, you need to break it down to the cellular level and understand that even then there's one step further to go. So what we've done here is we've said chloroplasts are the ones that are giving off O2 and C6H12O6 through the process of photosynthesis. And then through the process of respiration, mitochondria are taking that in and giving off H2O and CO2. Now, so each color, the blue represents what you usually use in ecology. The black represents right here in the middle what you normally what you've used since you're in like third grade. And then down here we want you to understand it at like the biochemical level. But understand that it's not just complex cells that do this. You also have some bacteria that undergo something similar to photosynthesis, so that would fit with the same thing that chloroplasts are doing. The other thing that's true is trees don't only do photosynthesis. At night, they kick into respiration. So trees have mitochondria in their cells as well, especially in places like their roots and their stems where there's nothing green, where they can actually consume some of the sugars they've made and use them to make energy while they give off CO2 and H2O. They do the same thing in the wintertime or when they're dormant. Now this is the short-term carbon cycle. This can go forward in as little as minutes or as much as, say, years. But then there's another carbon cycle to understand that's been at play as well, and that's what I call the intermediate carbon cycle. That carbon cycle is when you get sugars that are formed primarily from algae. If we're talking about the formation of oil, algae out in the ocean, it sinks down to the bottom, gets covered up by a landslide, buried under heat and pressure, and it turns into fossil fuel or oil. This takes millions of years to form very much oil. It's almost impossible for it to form today the way that it would have hundreds of millions or billions of years ago, hundreds of millions of years ago. And now those fossil fuels, we are burning them and putting them back into the atmosphere. But we're not doing it over millions of years, so that cycle has been artificially influenced. So now you've got this massive arrow worth of material dumping CO2 into this short-term carbon cycle. Now, there is another carbon cycle that takes even longer, and the one that is further out here. This one is when you get sugars that are actually taken up and used by things like corals or diatoms, and they actually build a shell where they combine that carbon dioxide with calcium carbonate, right? So they're using this up, turning it into calcium carbonate, and that becomes limestone. Here in Missouri, we have a lot of that. Every time you drive through a road cut that has white cliffs on the side, that's limestone. Limestone only turns back into CO2 when it interacts with acid or something else that's going to actually dissolve it and free that CO2. Now, that dumps it back into this short-term carbon cycle here. But the one we're really concerned about is this. This is the source of most of your global warming gas. And not only does oil contribute to it, so does every other fossil fuel, with coal and oil being the greatest offenders. Coal is when you get peat moss that's buried. Underneath that peat moss ends up being compressed over time, turns into subbituminous coal, then bituminous coal, then anthracite coal. And the anthracite's the stuff we really like to dig up because it's energy dense, but as we burn it, we free all of that CO2 to go back into the atmosphere. So this is the carbon cycle I want you guys to understand for the purposes of my class. There's the really simple one on the inside that was just the O2, C6H12O6, gives off the CO2 and the H2O as it comes out of the animal. But then I want you to be able to convert it to the producer-consumer version and the chloroplast mitochondria. Once you've got that, add the fossil fuel intermediate cycle, and then add the limestone outer cycle.